with some strings, woo, do, 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 and a hole behind there, right? And the string is plucked, okay? And a standing wave forms on the string, okay? So that's what we've got to figure out, okay? So this is, how many should we make it? Shall we make it 4 marks? Let's imagine that they're being generous this year. And it's 4 marks for describe and explain how a standing wave is formed. Right now, remember the structure of explain is key fact, consequence. And remember the structure of describe is say everything that you see, including numbers. Right, now, everything that you see is figuring out what happens in order and then describing it, okay? So what I'm going to do now is I'm going to stop sharing this a minute. I just want to quickly show you the Walter Fent. If you've not come across him before, you need to go to Walter Fent and his simulations. Okay, so I'm just going to share this with you. Put your sunglasses on. You'll see what I mean in a minute. There we go. Okay, so Walter Fent, I think he must be German with a DE extension on his website. But anyway, these are correct simulations. So I love these. They do not belong to me. So, and you can download them and things if you want. Right, what we're going to do is we are going to do a standing wave by superposition with a reflected wave. So, and I just want you to see this standing wave form, okay? So remember that it is describe and explain how a standing wave is formed. Basically, your description is this. So you have to say that there is a progressive wave which travels along the string when the string is plucked. What happens to that progressive wave? It hits the end of the string, which is a node, it's got to be a node, and it reflects. Da, da, da. The blue wave is the reflected wave. And the blue wave and the red wave, so these waves that are now going in opposite directions, they superpose, they interfere, and the black dots are the standing wave that's formed. Now, you need to describe, because we're describing and explaining, that there are nodes where the bits of the string that are nodes, that those don't move. And there are antinodes where the two waves constructively interfere and they form a large oscillation. And the energy is stored, it doesn't travel anymore. Okay, so this is what you have to describe right now. I have just received a question. What is the difference between interference and superposition? So interference is where one thing affects another. Superposition is where you've got two waves and they overlap, so they interfere, and the waves superpose. They literally add to each other. So superposition is a type of interference here, yeah. Okay. Okay. Right. So this what you saw, that's what you have to describe. Oops. Right. I don't want that, do I? I want to go back to my whiteboard. Where's my whiteboard? Come on. So here's my whiteboard. So now what we've got to do is we have to say everything that we see, and then we have to explain it. Okay, or we could do it the other way around. But I think describing what you see and then explaining how the standing wave is formed makes more sense in this situation. So what will we start with? What's the starting thing for the description? What do we start with for a guitar? The string is plucked, isn't it? Right. So the string is plucked. And then what? A wave travels to the end, okay, which is fixed. So you could put fixed end, right? And what happens? It's reflected. Okay, so now we've got two waves going in opposite directions. Now that is the condition for superposition. Okay, that is the not for superposition, for a standing wave, right? You have to have two waves. They've got to be the same frequency. They have to be the same type of wave. They've got to have approximately the same amplitude. They must be going in opposite directions for standing wave to form. Right now, the wave going in the other direction is not always reflected. It might be that you've got two loudspeakers and they're pointing at each other, and if they're driven by the same signal generator, they will superpose and interfere, and you'll get standing waves. Coherent is not the same as traveling in opposite directions. Okay, Ashritha, that is a really excellent question because it's really quite subtle. Okay, coherent waves are waves which have a constant phase difference between them, usually 0. But if waves are traveling in opposite direction, it makes no sense to talk about the phase difference between them. It's constantly changing. So coherent waves are waves which come from two sources, usually side by side. And coherent waves have a constant phase difference between them. They have to have the same frequency, wavelength, speed. They must have approximately the same amplitude, although it doesn't have to be exactly the same. And they have to be traveling in the same plane to be coherent. So they have to overlap. Okay. And then, so when you're talking about young slits, or when you're talking about diffraction grating, or when you're talking about an interference pattern like that, then you can talk about coherent sources. But the requirements for standing waves are that you've got, again, waves with the same frequency, the same wavelength, approximately the same amplitude, traveling at the same speed. But here they have to be going in opposite directions. So there isn't a constant phase difference between them. It keeps changing. And so you can't talk about the waves that cause standing waves being coherent. It doesn't make sense. So it's quite subtle though, isn't it? So you can get superposition and interference from coherent waves from two or more sources, but you can only get standing waves if you've got waves going in opposite directions, and that requires that they are not coherent. Doesn't make sense that they are coherent. Okay. Right, it's quite subtle though. It's really good that you asked because now I was able to say that. Right, okay, so the string is plucked and a wave travels to the end and is reflected. Right now, that first statement, which is a description of the first thing that would happen, that is not always there. So like I say, if you don't have a reflection, if you've got two sources that they're pointing at each other, you can still get a standing wave. But if the second wave is caused by a reflection, then you will need to say this. Okay, so then what happens? the two waves that are traveling in opposite direction, they superpose. Okay, these two waves, these oppositely traveling waves, superpose and interfere. Why not say both? Okay, and what happens? Nodes are formed where the waves cancel each other. Okay, and we talk about this as destructive interference. But where that you get two crests together or two troughs together, then they add. Okay, so antinodes are formed where the waves destructively interfere. Okay, and if it's a guitar string, what can you say about the ends of the string? Oh, yep, I've done destructively twice. Well spotted, my deliberate mistake, Vedant. Very, very good. Right, where waves constructively interfere. Well done. Thank you, thank you, thank you. Really, really good. You get a star. I'm going to give you a star. Oh, give you a star. Come on, I want a star. There we go. Thank you very much for saying that, because I would have got that wrong and that would have been wrong in the recording and everything. Oh, okay. So antinodes are formed where the waves constructively interfere. Yeah. And then, right. So 2n and 2n plus 1, what's that to do with? That's to do with path length, isn't it? And they're traveling in opposite directions. What path length are we talking about? See, it doesn't work, does it? Can you see how there are things that are subtle? There are things that are subtle. Right, at the end, they form nodes. Okay, so you get nodes at each end. And the fundamental one is the standing waves that formed, they're the waves that fit. Okay, so and the fundamental one is where you've got one antinode, which is in the middle, and nodes at each end. And the fundamental frequency or wavelength um, has one antinode in the middle. Right now, this is only true for strings. If you've got um, a standing wave formed in a tube of air, like a recorder or a flute or a bassoon or something, right? Then you have your tube of air. If it's closed at one end, imagine a pipe that's like, oh, you can imagine blowing across the top of a bottle or something, right? If it's closed, then you get a node there and you'll get an antinode at the open end. If it's open at both ends, then you get antinodes at the ends, and the node, the fundamental will have just one node and it will be in the middle. Okay, so this is the fundamental where you've got quarter of a wavelength. That was rubbish, Alison. Let's try that again. I'm going to change colour. Like that. And like that. That's a quarter of a wavelength, lambda over 4. And this one does that. Again, both of them rubbish. Let's try that once more. Something like that. Okay, and this one is lambda over 2. Okay. Each time for the next harmonic, you get an extra node. So, and that's what happens. That's the next harmonic up. And so if you get 2 nodes, it will be 2, instead of half a wavelength, it will be a wavelength. And here, if you get an extra node, then it will be 3/4 of a wavelength for the length of the tube. So it does depend on exactly which mode you are in, and whether or not the ends of the tubes are fixed by being closed, or fixed if it's a string, or antinode because it's not fixed if it's an open end of a tube. Okay, so now I hope that this has shown you how to describe how a standing wave is formed. Right, now, have we explained it as well? Okay, what are the conditions that are required? What's the key fact? So the key fact to get us to explain how a standing wave is formed is you've got to have waves traveling in opposite directions, and they have to superpose and interfere. So there's my key fact. And the consequences, you get constructive and destructive interference, you get nodes and antinodes. So this is my key fact, and these are my consequences. So you can see that the describe bit and the explain bit are kind of mashed together here. And describe and explain quite often go together like that because of this effect. So your describe, remember, it's a physics describe. It's describe everything that happens, preferably in a logical order. So usually in the order that they happen in time, chronological. But also the explain bit is key fact. We've got to add the consequences of that. So can you see? You have to find your starting point. Can you see here that my starting point is the string being plucked, the wave traveling, and then a wave being reflected? This is a key fact, and it is also the first event in the sequence of events for our description. And that's why describe and explain quite often go together. Okay, so and I want you to be aware of this structure. It's this structure that will help you answer not just this question about how standing waves is formed, but every explain and describe question. Right, now, you do also have to use the right keywords. So when you are talking about the describe and explain how a standing wave is formed, you must talk about the waves traveling in opposite directions. You must say superpose. You must say interfere. You need to talk about destructive and constructive interference. You need to talk about nodes and antinodes. These are the key words, and they need to be scientific. Okay, so you need to use the right words. And this is one of the reasons why you should practice, especially doing the describe and explain questions that come up frequently. So this is describe and explain how a standing wave is formed. One that comes up about every 3 years is describe how a transformer works. One that comes up about every 3 years is describe how kinetic theory leads to the idea of pressure and or temperature. So there are some describe and explain questions that it's worth learning. So yeah, and this is one of them. It's become less important because nowadays this answer would get you 2 marks, not 4.